Okay, so in lesson 14, we're finding the equation of a line. If we know 2 points on a line, we can find the equation of the line. Example 14.1 says find the equation of the line that passes through the points -3, 2, and 3, -3. So we can plot those 2 points. So we're going to go 3 to the left and 2 up, and that'll be -3, 2. And then we're going to go 3 to the right and 3 down, and that will be 3, -3. And when we want to write the equation of a line, we're going to write y equals mx plus b, where m is the slope and b is the y-intercept. So if we draw that line, we can figure out that it has a negative slope. It's going down. So we're going to put a negative sign right there in that first blank to show that the slope is going to be negative. And then we can see what the slope is. If we go from point to point, we have to go up a certain amount, which in this case is 5 units up, and then 6 units to the left. So that is -5/6 for the slope. And then we want to find out what the y-intercept is, but it's not completely clear just by looking at the graph what that y-intercept is going to be. So what we're going to do is we're going to take one of the points that we know is on the line, and we are going to plug it into this equation and for x and y, and then we will solve for b, which is the y-intercept, and that way we'll know what that is. We're going to plug in -3, 2, so we'll put in 2 for y and -3 for x, and then plus b. So b is our y-intercept. So if we multiply this out, we're going to have 15/6 plus b, and then that would be 12/6 minus 15/6 is going to be -3/6, which is -1/2, and that is b. So we'll put that into that blank, and now we know the equation of the line. It will be y equals -5/6 x plus -1/2, or -1/2. Okay, we can also find the equation of a line if we are given a point and the slope. So we're told that the line goes through the point -4, 7 and has a slope of -3/5. So we can plug that slope into the equation for m. Y equals mx plus b. M is -3/5, and then we don't know what b is. So we're going to use the point -4, 7 and plug that in for x and y to figure out what b is. So we'll put 7 in for y, and we will put -4 in for x, and we'll have 7 equals -3/5 times -4 plus b. We can multiply that out, and we'll have 7 equals 12/5 plus b. Subtract 12/5 on both sides, and that's going to be b, and 7 is 35/5 minus 12/5 is 23/5. So that is what b is. We'll put that back into the equation for b, and our final answer will be y equals -3/5 x plus 23/5. Okay, lesson 15 talks about elimination. So elimination is a way to solve a system of equations, and we have used substitution to solve a system of equations, and now we're going to talk about using elimination. We know that by the multiplicative property of equality, we can multiply both sides of an equation by the same value, and the solution set will not change. We know that by the additive property of equality, we can add the same value to both sides of an equation, and the solution set will not change. So we can use those two properties to solve a system of 2 equations and 2 unknowns in a process called elimination. So we have this system of equations, 2x plus y equals 11 and 3x minus 2y equals 6, and we want to find out the coordinate pair x, y, which will work in both equations at the same time. We're going to look at the x coefficients in both equations, and we're going to look at the y coefficients in both equations and see if either of those look like they might be opposites. So 2x and 3x. 2 and 3 are not opposites in any way. Plus y and minus 2y are close to being opposite. You've got a positive y and then you've got a negative 2y. If you were to multiply the first equation by 2, then you would have opposite values for your y coefficients. And then you would be able to make those two things cancel by adding the two equations together. So we're going to multiply the first equation by 2 so that we can make that happen. So if I multiply the whole first equation on both sides of the equation by 2, I'm going to get 4x plus 2y equals 22. And then I'm just going to rewrite the second equation. I'm not doing anything to that. And now I can add the two equations together because 3x minus 2y is the same thing as 6. So I can add that same thing to both sides of the first equation. So if I add those together, the two y's cancel, and I'm going to end up with 7x equals 28. So x equals 4. And now I can take that 4 and plug it back in to the first equation to see what y is. So 2 times 4 plus y equals 11. So I plugged that in. So that's 8 plus y equals 11. So y is 3. And so we can check to see if x equals 4 and y equals 3 work in both equations. So you've got 2 times 4 plus 3 does equal 11. And then in the second equation, you've got 3 times 4 minus 2 times 3. 12 minus 6 is 6. So it works. Your answer is going to be the point 4, 3. Okay, here's another example. This one, the x coefficients have opposite signs, but they are not the same coefficient. So we're going to have to, in this case, we're going to have to do something to both equations so that we can get the x coefficients to be exactly opposite to each other. So since you have a 3 and a negative 2, you want to look for the least common multiple of those two things, which is 6. And we want to make the x coefficient in the first equation positive 6 and the x coefficient in the second equation negative 6. So what we can do is multiply the first equation by 2. And we're going to multiply the second equation by 3. So if we multiply the first equation on both sides by 2, we're going to have 6x plus 4y equals 46. And then if we multiply the second equation through by 3, we're going to have negative 6x plus 9y equals 6. So now we can add those two equations together. The x's cancel, and we have 13y equals 52, which means that y is going to be 4 if we divide both sides by 13. So now we can plug that 4 back in for y in the second equation, or either equation, and we're going to have negative 2x plus 3 times 4 equals 2. And then if we multiply that and subtract 12 on both sides, we're going to have negative 2x equals negative 10. So x is going to be 5 if you divide both sides by negative 2. So you've got the point 54, and we can check that to make sure that it actually works in both equations. So in the first equation, you've got 3 times 5 plus 2 times 4 is supposed to equal 23, and that is 15 plus 8, which does equal 23, so that works. In the second equation, you've got negative 2 times 5 plus 3 times 4 is supposed to equal 2. That's negative 10 plus 12 does equal 2, so that works. And that is the solution to this system of equation. So lesson 16 is about multiplying and dividing polynomials. To multiply two polynomials, we just use the distributive property. So I have 2x plus 2 times 3x squared minus 5x plus 2. So what I'm going to do is I'm just going to multiply the 2x by everything over here, being very careful to put my pluses and minuses where they belong. So that's the first thing I'm going to do. So 2x times 3x squared is going to be 6x cubed. And then 2x times negative 5x is going to be minus 10x squared. And then 2x times 2 is going to be plus 4x. So I'm done with the 2x. I have done all the pieces. And now I'm going to do the 2. So I'm going to multiply the 2 times the 3x squared. It's going to give me plus 6x squared. And now I'm going to multiply the 2 by the negative 5x. So minus 10x. And now I'm going to multiply that 2 by the last 2. So that'll be plus 4. All right, so I have distributed everything. I've been very careful about all of my signs and things. So now I'm going to group together my like terms. So 6x cubed is the only x cubed term. So that has nothing to combine with. So that'll just be 6x cubed. And then I have a minus 10x squared and a plus 6x squared. So that adds up to minus 4x squared. And then I have a 4x and a minus 10x. So 4 minus 10 is negative 6, so minus 6x. And then I have the 4 at the end, and that's it. So that's all I can do, and that is how you would multiply those two polynomials. Okay, so now I have these two polynomials that I want to multiply. It might be a little bit easier to use the commutative property of multiplication and put the shorter one first instead of second. So x minus 2 times 3x squared minus 2x minus 2. But you can do it either way. Doesn't matter which one goes first. So I'm going to start with the x. I'm going to multiply the x times the first term in the second polynomial. So that'll be x times 3x squared, which will be 3x cubed. So x times negative 2x is going to be minus 2x squared. And lastly, I'm going to multiply that x by the negative 2. So negative 2x. So that's all I needed to do with that x. And next I'm going to do this negative 2. So minus 2. Minus 2 times 3x squared is going to be minus 6x squared. Minus 2 times minus 2x is going to be positive 4x. And then negative 2 times negative 2 is going to be positive 4. So I distributed the x, I distributed the negative 2, and now I'm going to add my like terms. There's only one x cubed term, and that is 3x cubed. Then I have 2x squared. I have 2x squared terms, minus 2x squared minus 6x squared. That adds up to negative 8x squared. And then I have a minus 2x and a plus 4x. That's going to give me positive 2x. And then I have plus 4 at the end. That's all I can do. To divide polynomials, we use the same process we use with regular long division. So let's just look at that and remember what the steps are. The steps for long division are divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. You just keep doing that over and over until you're done. So we're going to start by dividing. You divide 6 into 1, it's not going to happen. 6 into 12 goes 2 times. So we'll put a 2 here. Now we multiply. 2 times 6 is 12. Now we subtract. 12 minus 12 is 0. Now we bring down. Bring down the 3. 6 divided into 3 doesn't happen, so we got to bring down the 4 also. 6 goes into 34. Well, first of all, the 3, we couldn't divide 6 into 3, so we had to put a 0 here. 6 into 34 goes 5 times, so 5 goes here. Now we multiply. 5 times 6 is 30. Now we subtract. 34 minus 30 is 4. Now we bring down the 5. Now we start over. 6 goes into 45. We divide 6 into 45. That is going to be 7. Now we multiply. 7 times 6 is 42. Now we subtract 45 minus 42 is 3. And there's nothing left to bring down, so this is going to be our remainder. If we divide 12,345 by 6, we get 2,057 and 3/6, which is the same thing as 2,057 and 1/2. So this is what you do for long division. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. So let's try it. All right, so we're going to divide 2 plus 5x minus 2x squared plus 5x cubed by negative 4 plus x. When we set this up, we are always going to set it up with the highest power of x being on the far left. And we go down, 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 down until we get to a constant. When we set this up, we're going to put x minus 4 on the outside. And then we're going to put the polynomial under the bracket, starting with the highest power of x and going down to the constant. So 5x cubed comes first, and minus 2x squared plus 5x plus 2. And now we divide. X goes into 5x cubed, 5x squared times. You're looking for the number that when you multiply it by x, you get 5x cubed. So that would be 5x squared. Now we multiply. 5x squared times x is 5x cubed. 5x squared times negative 4 is negative 20x squared. Now we subtract. 5x cubed minus 5x cubed is 0. Negative 2x squared minus negative 20x squared is positive 18x squared. Now we bring down the 5x. Now we divide again. X goes into 18x squared, 18x times. Multiply, 18x times x is 18x squared. 18x times negative 4 is negative 72x. Subtract 18x squared minus 18x squared is 0. 5x minus negative 72x is positive 77x. Bring down the 2 and divide again. X goes into 77, 77 times. Multiply, 77 times x is 77x. 77 times negative 4 is negative 308. And now we subtract. 77x minus 77x is 0. 2 minus negative 308 is positive 310. And that is our remainder. So our final answer is going to include that remainder. Right here, we will call that plus 310 over x minus 4. Now we are going to divide negative 6 plus x cubed by negative 2 plus x. So we're going to start with that negative 2 plus x. We're going to write it as x minus 2 because we're going to start with the highest power of x going down to the constant. And then under the bracket, we are going to write this. We're going to start with the highest power of x. And for any powers of x that we don't have, we're going to put a 0 for each one. That way we will keep everything organized and lined up correctly. So we've got x cubed, but we don't have an x squared term, so we're going to put 0x squared. We don't have an x term, so we're going to put 0x. And then we're just going to put minus 6. So we have to include a placeholder for every power of x to keep this organized. And now we do the division. X goes into x cubed, x squared times. Multiply x squared by x, which is x cubed, minus 2x squared. Subtract x cubed minus x cubed is 0. 0 minus negative 2x squared is positive 2x squared. Bring down the 0x. Now we're going to divide. X goes into 2x squared, 2x times. Now multiply 2x times x is 2x squared. 2x times negative 2 is negative 4x. Subtract 2x squared minus 2x squared is 0. 0 minus negative 4x is positive 4x. Bring down the negative 6. Divide, x goes into 4x 4 times. Multiply, 4 times x is 4x. And 4 times negative 2 is negative 8. Subtract 4x minus 4x is 0. Negative 6 minus negative 8 is positive 2. And that's our remainder. So we will put that as 2 over x minus 2.